So what the reason why I don't just dive into the booklet is because I feel like there needs to be some background uh, on this, right? Surface area, the areas of all faces I should say, of a 3D object. You can also think of it as the area of the net diagram. So if you have a pyramid, so you're gonna have to be pretty good at, or get better at uh, drawing 3D objects. So if art isn't your thing, I'm right there with you. Okay, I feel your pain. Right. So basically, we're gonna try to make a pyramid. Right. So this would be the pyramid. And if you have to erase, that's fine. This is, and there are two pyramids in particular, but we'll just refer to this as a pyramid, right? It's a 3D object. And if you lay this out flat, if you were to open it, let's say at the top, and you would have a shape that looks like this. You have a square, that's the base, and then you'd have triangles coming off each of the sides of that square. So this is called a net diagram. So surface area of this pyramid, or any pyramid in general, would be area of base plus area of 4 triangles. In a sense, you would be finding the base, which is a square in this case, and then obviously if you find the area of just one triangle, you just multiply it by 4 to get that. But this, I just need you to understand the concept of surface area. And once we get into word problems, sometimes we will not be including all of it, right? We'll be excluding the base sometimes. So you have to watch out and read carefully. All 3D shapes covered in this course are also called prisms. We only study bright prisms. And that just means that the height of this thing will always be measured at a 90-degree with the horizontal, with the ground. So there isn't any like inclined prism or anything like that. When asked how much paint or fabric or cardboard etc. is required, you should think surface area. Okay, so if a question asks you determine the amount of paint or fabric or cardboard, anything that appears to be covering or wrapping around that shape, right? You should be thinking surface area. Okay, and note, unless stated otherwise, we assume that all faces are included. Read question carefully. I'll do attendance in a bit in case you're wondering. Just wanted to get us started here. And now we're going to go into the formulas. So rectangular prism. This is basically your classic box, right? That's what a rectangular prism is. Pause for a bit. So rectangular prism, you kind of need to, I'm going to have the prism leaning this way. So I'm going to start with my face here. It's going to be the face like that, and then I'm going to go in an incline towards the back like that. And then we'll make the three, like the see-through, we'll make this a see-through box. And then it doesn't really, the height is obvious, right? The height is going bottom up, right? But length, width, it doesn't really matter which one is which as long as you label it. It's not necessarily that the longest side is the length, right? It's just length, width, and height. And so surface area here for a box like this would be top and bottom. And there's a reason why I group it up like this, top and bottom, plus front and back, plus sides. And there's two of each, of course. So how does that translate by using the actual variables that I have here? Because later on you're going to be doing word problems on this. So surface area, top and bottom would be length times width. So there's two of them. 2 times length times width. Okay, plus 2 times length times height plus 2 times width times height. That'd be the surface area of the entire box. And here I'm going to give you a little hint. Within a word problem, notice that there, if you look at the whole formula here that I just gave you, these two involve the height. I don't know if you see that. Now you should, right? So it's basically in a room, that'd be the walls around the room. Okay. So what we do, I will also highlight the height here. Okay. So what I call this, to make students aware of this, the length times width, so length times width multiplied by 2 would be the top and bottom, and we call that floor and ceiling, like floor and ceiling. Right, so if there's a question where you're trying to figure out how much paint you need to paint that whole room, if you're intending to paint the floor and ceiling, yes, you would include this part. But most of the time we definitely don't paint the floor. Sometimes we paint the ceiling, right? So you need to be aware of that. And these two expressions towards the end of that formula would be considered the walls of the room. Okay? This is including everything. We have something called lateral surface area, and I will refer to it as the LSA. Lateral surface area means that only the walls, only the sides of that is what you're asked to find. Okay, so it'd be 2 times length times height plus 2 times width times height. So you're essentially dropping that length times width. 2 length times width is gone. If you're asked to find the lateral surface area, it's only the sides of that prism that you're asked to find. If you're trying to find paint for just the walls and ceiling, or ceiling and walls, right, which is most likely going to be the case, that would just be length times width plus 2 times length times height plus 2 times width times height. And notice this, right? I want you to first write it down, and then I'll highlight that part. This is the ceiling, and these are the walls. And maybe instead of just having length times width here, I'm going, both of these formulas that I'm giving you are derived from the original, which includes everything, right? Lateral surface area, we did not include the floor and the ceiling, or also known as top and bottom, so we completely eliminated that here. And notice that from the original, we had 2 times length times width because we had the floor and the ceiling. Now it's just the ceiling, so technically there's a 1 here. You don't have to include that, but that's really what's happening. This formula is now down to just 1 times length times width because we're not including the floor. Not including floor. Okay, that way it's a reminder. Okay, Louis, you're here? Okay. back side. Now we're going to talk pyramids. I don't know if I want to do, okay. Next shape we're going to look at is pyramids. And the first one would be the square base pyramid. Just one slant height. Okay, the square base pyramid only has one slant height, and I will draw and label that for you here. So kind of make like a parallelogram almost. And I always go a little bit off, like don't center it, just have the top a little bit off to the side, and then connect with each corner. It's not the best, my best work of art there. Maybe I'll redo that one. Try to. I'll make this more like this. Make it more like a diamond. Let's see if it works this time. Okay, so a square base pyramid, all these sides are the same. Okay. So this would be we call this B. This is also B, right? Because they measure exactly the same. And here you have to be careful because you have, and I'll use a different color for this, along the face, each face has a slant height. Like this. Right? So this is a slant height. And we call that S. Okay? And then I'll use a blue one to determine the actual height of this thing. The actual height is measured from the center of the base, right, to the top. And this is the height. Height H. So there's a slant that goes along the face, and there's the actual height that goes from the top to the center of the base. So it'd be halfway this way and then halfway in. So it's essentially right in the middle, and it makes a 90 with the ground. Okay. And so to find the surface area of this, of a pyramid, and this is a square base pyramid, right? It would be B times B, so it'd be B squared plus, technically there are 4 triangles, right? 4, and here it gets a little tricky, but we'll make this formula, we'll simplify this. Each triangle as base, right? The base of the triangle times its height. The height of that triangle is S, okay? Divided by 2, right? Area of one triangle. Base times height divided by 2. That's the area of a triangle. And if you forgot that, I will just point out to you in your formula sheets. I'll just point out that you have the Pythagorean theorem here. This right here, area is half base times height. This is really the area of a triangle, right? Base times height divided by 2. This is the circumference of a circle, and this is the area of a circle. So the basic shapes are here. And it reminds you some of the surface, like the surface area, right? Area of faces plus area of base. That's the idea of the surface area, right? And you're given 2 here, which in a bit we're going to get to. But the one for the prism, the box we just did, as well as the pyramids are not in here. Okay, so those are not, you're not going to find them in here, so you got to memorize them. Okay. Anyways, so surface area is b squared. This is area base, right? This would be your base. It's b times b. That's where this comes from. And then you have 4 triangles, and this is the side. This is the area of just one triangle. Okay. Notice that nowhere in here do you see the height. Okay, very important to determine that. Okay. So simplified version, surface area of pyramid would be b squared. And if you notice that this is a 4 and that's a 2, because this is all multiplying at the top, you can actually reduce this. The 2 goes in here 2 times, the 2 goes in there 1 time. So it reduces to just 2 times b times s, right? This is the surface area of a pyramid. Memorize. Okay. The LSA of a pyramid, the lateral surface area is just the sides, would just be 2 times b times s. It will just be this part. Okay. Memorize as well. Although if you memorize the original, then it's easy to just know, oh, you just have to know what do these represent. Keep in mind that 2bs represents all 4 triangles, but it's reduced. It came from this original one. It's 4 times, so some students put a 4 in here. Again, it's 4bs. You would get it wrong in that case. It's 4bs divided by 2, which reduces to 2bs. Okay. Okay. Keep going with the rectangular pyramid. Will I do rectangular pyramids? I will. Can you do this for me? Write this down and then leave about half a page for it. And then we'll continue with the other shapes, because that is one potentially that we omit during COVID season, COVID pandemic times. So I'd rather not spend too much time on that and do the other shapes. So this one time permitting. Okay, so leave that space in case I need to go back and cover that. It gets more complicated than that. And as I'm going through this, allow me to just add one more thing to this. Okay, so it's not going to take a whole lot of room, I promise, but sometimes you'll have to find the slant height. Okay, so if you think about it, if you consider the triangle that's formed by the height, right, and the slant height, that'd be this one right here along the face, you're literally slicing a triangle out of that. So this is your slant. The one that goes straight down the pyramid is your height, and B, this, if whatever B is, this would be B divided by 2. Okay. This is what you're going to use. This is what you're going to use to find either the slant height, right? You're going to need the slant height if it's not given. So slant is going to be the square root of h squared plus b divided by 2 squared. And this comes from the Pythagorean theorem. Okay? And while we do examples, that's going to come up again. Because you're essentially finding the hypotenuse of that triangle. Okay? So there's that. Okay. So leave half a page. And we're going to do surface area of cylinders and cones. And I know for some of you this is review, and that's great, but there's little things that I'm preparing you for, surface area of cylinders, that you may not have seen before, and make it easier for you to be successful later on when you have problems, because you're going to have word problems that you need to solve for. Surface area of cylinders and cones. And the reason why I group them is because they are related, right? Cylinders and cones are related. Prisms and pyramids are also related. You'll see that later. Okay? So you have a cylinder, and it just basically has 2 circles and the side, right? So this would be the height from top to bottom. And the radius is from the middle center of the circle going out. That's the radius. And this would be a cylinder, of course. So in real life, right, it would be a cup of can or something like that. So we will use this for word problems. So if you think about it, if you were to draw the net diagram of this, you'd end up with, right, if you would cut the side somewhere and open it up, and it would look like this. You would end up with a rectangle. And 2 circles. So anywhere you want, you have 2 circles like this. Okay. Where this is still the height, right? The height stays the same. The length of this would be 2 pi r. And if you remember, 2 pi r is the circumference of a circle. So, right, the circumference of the circle, because this side piece has to wrap around the circle. So naturally, the length of this sheet, or whatever you want to call it, would be 2 pi r. That's the circumference of the circle. Okay. So, and one of these, right, each circle has its own radius, of course, and they're the same. Okay. So you have everything you need to find a surface area of this shape. So surface area of a cylinder would be 2 pi r squared. And think about it, pi r squared is one circle, the area of one circle. So you have two circles, so we go 2 times pi times radius squared, plus this would be 2 pi r, that'd be length, 2 pi r, times the width, which we call height, 2 pi r h. Okay, so this right here is, you can consider it two circles, right? And this part right here would technically be considered the lateral surface area, just the side. If you just wanted the side of this and it didn't have a top and bottom, right? If it didn't have these two circles, it would just result in this. So the lateral surface area would just be 2 pi RH there. Surface area of a cup would just be pi r squared plus 2 pi RH, because you don't have two circles. A cup is open at the top, right? So it'd just be 1 pi r squared. No top, right? And this one is given to you, okay? I'll just cover it up. The order is just different. But right there, I will allow you to do this, okay? Under this, you can write down that this is a cylinder. If you want to do that, I allow you to do that, but don't add anything else, okay? And the order is different, and it doesn't matter which one you do first. But this, in a sense, is the most important one, and you can remove the components as you go, right? Okay, then we have cones. Surface area of cone. And there is a slant height involved here. So we draw our tent, so to speak, and we just draw a circle along as a base, right? And then going straight down to the middle, that's called the height, H. And this would be considered a radius, R. And this would be considered the slant, S. A net diagram of this would look like this. And somewhere along the bottom you have the base like this. So surface area of a cone would be pi r squared plus pi times radius times slant. Okay, this is the base. This would be considered the lateral surface area. And I should say that this is for a cone, right? also given to you in the formula sheet. They just reverse the order. So I'll just cover this up once. So if you want to put down cone here, that's fine with me. Okay. If you want to write down cone in your formula sheet. So if they wanted a surface area of a cup, you know those paper cups, right, that you get sometimes that look like a cone, wouldn't have this part, right? It would just be pi rs. That's all. Like if they ask you how much material do you need to make that cup, it would just be pi rs. You would not include the base there. So you have to look at the word problem and determine from it what you need to do. And last but not least, our sphere. And at first it might seem uh, quite straightforward. It's like, oh yeah, I'm just going to plug in and go. But I'll tell you that we're going to a point where we're going to work backwards. I'm going to give you the surface area, let's say, and you're going to have to find the radius or the slant height. So we're going to have to do some algebra there. So get comfortable finding the areas, surface areas, because we're working backwards later on. So sphere, what I start with is just a circle, and then I just make a dashed circle along the middle, kind of like an ellipse almost. So there's your radius. So surface area of a sphere is 4 pi r squared. And you can figure out which one it is in your formula sheet. It's also there, right? It's at the very bottom of there's side by side, there's a bunch of V's, and then there's a surface area that looks like this. So if you want to go on your formula sheet and write down sphere next to it, go for it. And then you have a hemisphere. This is the one I give you as well, but it's not on your formula sheet. So just make a half and then kind of just as if it's sliced in half. Okay. I used to not give this one, but I think you need to make sure you have this. This is your radius. And the reason why I cross off the top here is because this is not included in this formula. So it would be surface area of a hemi, right, would essentially be 4 pi r squared divided by 2, okay, because it's half of a surface area of a full sphere. So hemisphere, you divide it by 2. And you can see that, right, 2 goes in here twice, 2 goes in there one time. So it just reduces to 2 pi r squared. Surface area of a hemi plus the top, like if for whatever reason the word problem implies that it is closed, then you would have to go 2 pi r squared, that's just the outside shell, plus you'd have to add a circle to it. And how many pi r squares do you have essentially? Right? 2 pi r squared plus pi r squared, right? That is 3 pi r squared. It's interesting how that works out, right? Not so you got to memorize these ones or just know how it works. Okay. Okay. Now we're going to go back to continue to page 12 in booklet. Okay. That's the note I'm going to tell myself in case you don't take it apart. Like I have it taken apart so I know where it goes. And now we're going to do some actual calculations here so that it's not just the theory part of this. So you go to page 12 of your booklet. And a lot of this is repeating what I already said. The shape of the base determines the name of the pyramid. Slant height is the height of the triangular face. So there's the slant height is drawn out in all of these pyramids. This is a tetrahedron, by the way. Tetrahedron has all four sides as being a triangle. But once you get to the pyramids, right, the base changes to square, pentagon, hexagon. They could vary. We don't do, I think we go up to pentagon where it's a 5-sided, but not further than that. Okay. So let's do the first example here. Find the surface area. So they want the surface area of the following right square pyramid. Okay. And all of the ones we do are right. Okay. And we know it's a square pyramid. So we know that if this is 8, this will be 8 also, right? Like the base is 8 by 8. We're guaranteed that. And this is already like it's measured. It's indicating that's along the face. So this is the slant given. Okay. So when the slant is given, this is the easiest example you're going to have. So surface area here would be b squared plus 2 times b times s. And that's just 8 squared plus 2 times 8 times 10. You don't even need a calculator really here if you don't have one. 64. And this would be 20 times 8. That's 160. Right? And so surface area is 224. And here, watch this, centimeters squared. Okay. So the best is to start with your formula and then plug in and go. Okay. So 224 centimeters squared. There's a rectangular pyramid. We're going to avoid that for now. Okay, so we're going to keep going. Go to page 13. Okay, find the surface area of the following tetrahedron. And so we don't have formulas for everything, okay? I just covered the basics here. So tetrahedron has 4 triangles, okay? When you see that, you should know 4 triangles. So the surface area, if you just know the definition of surface area, in this case it would be 4 times base times height divided by 2. This is a triangle, right? 4 times the area of a triangle will give you the surface area of this. So in this case, we need to determine, like if you just look at this triangle, right? This is 4.3. This is technically the slant height of one of the triangles, right? Just one of the faces. And if this is 5, we know that this is 5 also here. Okay, this is 5, this is 5 also. So we can find the area of one triangle. This is going to be 5, right? 5 times 4.3 divided by 2. This is just one triangle, one face, right? So we're going to transfer this over to here, right? So you understand that this would be 4 times 5 times 4.3 divided by 2, like this. So I'm just transferring this over into here, plugging it in there. And if you want to, you can do this all in one shot right now with your calculators, right? Essentially, it's 4 times 5 times 4.3 divided by 2. Or you can do the inside first, 5 times 4.3 divided by 2, and then multiply that by 4. You should be getting 43 square meters. Make sure you have your equal signs like this as you move along. I'm just going to check here. We're going to come back to example 4 a little later. We're going to continue with surface area of right cones. So example 1. So again, a right cone surface area would be pi r squared plus pi rs. Pi r squared is the base, and this is the what we call lateral surface area. So if they want the whole thing, we add them up. If they just want the lateral surface area, we omit the pi r squared. And again, I will make sure you understand the difference between slant and height. There's a slant height, and there's the actual height of this. So make sure on this cone on the side here, you also make a distinction between the two. And you can tell that they form a right triangle, and we can use Pythagorean theorem to figure out the slant height if we know these two. Okay? So a right cone has a base of radius 4 and a height of 10. Calculate the surface area. Because of surface area, folks, you know you're going to need slant height. Okay? You need to know the slant height if they talk about surface area. In particular, when it's a pyramid or a cone, right? There's a slant, right? So we're going to figure that out first. So let's draw our cone just to have a visual here. right? If on the side you draw this, you know that this is 4. That's 4, the radius of the base. We know that across down the center, we know that this is 10. And that is our height. We need to know our slant height. So we draw that out. We cut out that right triangle. And we know this is 4, this is 10, this is going to be our slant. Not a 5, okay, this is a slant. So we know from the Pythagorean theorem that the hypotenuse squared, this is the hypotenuse across the 90, is going to be the square, right, of the sides added together. These are called legs, okay, leg and leg, hypotenuse and the 2 legs, right? So to find slant, it is essentially going to be square root of 10 squared plus 4 squared. Because you need to take the square root if something is squared, right? You need to take the square root ultimately at the end like this. And what we do in this course is we leave it under the root. Unless it's a perfect square, you leave it under the root because you don't want to round just yet. Don't round yet, okay? Make a note there. You do not round just yet. And I'm just going to make sure it says calculate the surface area, not lateral surface area. So we need the whole thing. So surface area is going to be pi. I know that it's radius squared, right? So I'm going to square it. That's based on this formula up here. Pi radius squared plus pi times radius times my slant, which is 116, root of 116, like that. Okay, and here's where having a good calculator is going to be a lifesaver. Okay, so I'll show you how to type this, how I type this in all in one shot. You should have a pi button. Don't use 3.14. You should have a pi button. So I have to press shift and then way down here on my calculator, I see that little pi. Some of you actually have a pi button, even better. But right, it's pi times 4 squared plus pi times 4 times root of 116. If you have a bracket, make sure you close it. Some of your calculators will put a bracket in automatically. And so you get 185.61. We round to 2 decimals, okay? That's the minimum, right? 185.61. And that is what units are we in? We are in meters, so we need to be in square meters because it's ultimately area, right? Surface area. So that'd be the surface area of the whole cone, like that. The U try here. This will be, I'll give you the answer to that one. That's 58.31. I'll put that on the side here. Answer 58.31 square feet. Okay, so make sure you try this one. I'll put a star there. That'll be part of your homework because the textbook doesn't have a whole lot on that. So you'll try that. It's the same thing. It's still a cone. It's just different information. See if you can do the same thing and get the right answer. Please don't forget units. It's so easy to lose marks there. Page 14. I'll just scan a little bit. Okay. Lateral surface area. I'll also give you the answer to that, and tomorrow I'll go over it. So just put it on the side here. 133.47 square meters. So this is another one I want you to try. Put a star on it. And notice the wording, lateral surface area, right? I emphasize that point there. And now we're going to work backwards. Working backwards. So that's where you have to go from area or lateral surface area back to finding the height. Determine the height. Okay. So they give you the lateral surface area. They give you that the diameter of the cone is 10, and they want the actual height. I will make a note here asking for a dimension, and that's missing side or something like that. Okay, you're missing a side or radius or whatever the case may be. That's called a dimension. Okay, and it's critical to know what your formula was to get there in the first place. It's the lateral surface area, right? Lateral, it's supposed to say surface area, right? Of a cone. So the lateral surface area of a cone is pi times radius times slant. Okay? And what do we know? We know that this is the lateral surface area right here. The diameter is 10 centimeters. The radius is going to be half of that, which is 5 centimeters. This is what I need in this formula. And I'm given the lateral surface area. So the 220 will go in here. Pi is a number. Radius I know is 5. Okay. And slant, I don't know what that is yet. Okay. So you need to isolate S. Okay. That's our goal here. Isolate that number right here. So essentially what we're going to do is, I'm going to use a different color. We're going to divide, because pi and 5 is multiplying S. So we're going to divide this side by pi times 5, and we're going to do the exact same thing to the other side, right? That way you're not altering the equal sign, the equality of this expression. Okay? And that allows us to do this. The 5's go, the pi's go, and so you're essentially just left with this. Okay? So slant is going to be, and here you have to be very careful. And this is going to be the last thing we do today. If you go 220 divided by pi, and then you go times 5, that's wrong. That's not going to be the right answer. You have to make sure this is in brackets, right? And I'll put a note here, invisible brackets. So we're going to do this when we enter that into our calculator. Okay? So this is what it's actually going to look like on my calculator. 220 divided by, I will start with brackets, and then I go pi times 5, like that. This is telling you that this is happening in the denominator, and whatever that is, that's what you're dividing 220 by. And it's 14.01. Earlier we got 350, right? When I forgot the bracket, so it's 14.01. And we are in centimeters, right? Everything is in centimeters. So this is a dimension, so it's just going to be 14.01. This is your slant. This is the slant height, but we're not done yet. We're asked to determine the height of the cone. Okay? So I'm going to graph it here. Okay? So this is slant, this is height, and this is radius. Okay? So you now just found what that was right there. They asked you for that, you found that, right? So we're asked for the height. We know that slant squared is going to be h squared plus radius squared. We know that slant here is 14.01. And we square that. Height is going to be squared. The radius we know is 5, right? Like that. So the 5 squared essentially comes over here to this side. So h squared is going to be 14.01 squared minus 5 squared. The 5 comes over subtracting. So h is going to be the square root of 14.01 squared minus 5 squared. So let's go ahead and figure that out. I do this all in one shot. 14.01 squared minus 5 squared. Close the brackets. That's 13.09 centimeters. And that is my height for this particular. So it's a lot of algebra there to get there. And I'll give you the homework here. I want you to try example 4 and example 5. And I will not give you the answers. Or should I? I think I'm going to give you the answer to 4 at least. Slant here is 9.50 inches. So try all the ones with a star that we just did, and I will go over them tomorrow. Okay? I need you to try those. Plus page 34, 4 to 13, and page 50, 3 to 5. Here you have spheres and cones, right? And I also want you to do 16 on page 34. Sorry, I just added that. So stars, this and this, okay? And that'll go over most of what we did today. So